Greetings and welcome to a chat with me, retired maths teacher. The intros I come up with. We are looking at paper 1 from the department, November 2023, question 5. Some graphy graphs. Question 5. I said question 5. Question 5! Just so I said it 3 times. Okay, cool. The graphs of f of x is equal to negative a half times x minus 1 squared plus 8. It's a parabola, right? And g of x is equal to d over x, which is hyperbola, are drawn below. A point of intersection of f and g is B, which is also the turning point of f. The coordinates of which we know, right? Because of, we've been given the parabola in turning point form, so handy. The graph f has x-intercepts at negative 3, 0, 5, 0, and a y-intercept at c. Okay, so before we dive into the questions, let's just also look at, like the information that's inside, that's encoded inside the function, right? So the negative a half over here, corresponds with the parabola being a sad face parabola, right? A concave down, right? Yes, concave down parabola, right? And then the 1 and the 8 give us the turning point of the parabola, right? They tell us that relative to, if you were to imagine your very plain parabola, y is equal to x squared, it would sit here, right? Its turning point would be at the origin. The negative, we've already said, okay, makes it now a downward facing parabola. Then the minus 1 means that this parabola moves 1 unit to the right, and the 8 means it moves 8 units up. Okay, and just for completeness, the half opens it up a bit more. So if your original parabola, as I like to call it, was maybe like this, then the half would flatten it a bit. Okay, right, then we've got g of x is equal to d over x, which is a parabola. How do we know that? Because we have an x in the denominator of the expression, yeah. And because we don't have an x plus something or an x minus something, as in the denominator, and also j as a constant being added to this fraction term, then we know that relative to the original hyperbola, y is equal to 1 over x, this new hyperbola hasn't moved left or right, up or down. So the asymptotes are still the y-axis and the x-axis. The d, so we can see that our hyperbola lives in the first and the third quadrants. So that hints to us that the d is positive, because if we're negative, then our hyperbola would live there and there. So we know that it's a positive number, and then it's just a matter of like how steep is this hyperbola, or maybe it's been flattened a bit as well, depending on what d is. Anyway, okay, so those are some things that we can tell just by looking at the respective functions, their definitions. Right, so the first question, 5.1, says write down the coordinates of the turning point of f. Okay, and we've spoken about that. We can already read it from the function as it's been given to us. So the turning point, which is b, is positive 1 as the x coordinate and positive 8 as the y coordinate. Okay, then the next question says calculate the coordinates of c, the y-intercept of the parabola. So we will calculate the y coordinate by making a big yawn. Oh my gosh. We calculate y-intercept by figuring out, okay, what is the value of the function when x is 0? So that is negative a half times 0 minus 1 squared plus 8. which is negative a half times minus 1 squared, which is 1, plus 8, which is 7 minus a half, not 8. 8 minus a half, which is 7.5, which is the same as 15 over 2. So, therefore, the coordinates, yay, the coordinates of C will be x is 0 and y is 15 over 2. Okay, and then the next question asks us to figure out the value of d. Okay, and in order to do that, like, the only point we've been given really on this hyperbola is b, which is the turning point of the parabola, right? So we can use that, we can sub that into the function. So we know that from point B, using the point B, right, we know that when x is equal to 1, the output of the function is 8. So when x is equal to 1, the function is d over 1, and we know that the output is 8, so d is equal to 8. Okay, and then last question on this page. Write down the range of g, the hyperbola. Okay, so we know that this function outputs every y value except this guy, except 0. There's no x value that can give us a y value of 0. So the range of g of x is g of x is anything but 0, right, if we consider real numbers. Right, so that's that on that. Let's check with the memo if we're on the right track so far. I don't even know what question we're doing. Question 5. Question 5. Yes, okay, everything looks good so far. Right, so on we go to the next question, and we're just going to start by filling in what we know already. So b is 1 and 8, c is 0 and 15 over 2, and then we know that d of x, oh, that's actually 8 over x, not d of x, d over x. I know that the d is actually 8. Okay, cool. So the next question says, for which values of x will f of x times g of x be smaller than or equal to 0? Okay, so we're looking at two cases, right? Okay, so we're looking at the case where f of x is greater than or equal to 0, and both g of x is smaller than or equal to 0. So that's the first case. Then the second case we're looking at is where f of x is smaller than or equal to 0 and g of x is greater than or equal to 0, right? So that's the only way that we're going to get a product that is negative or equal to 0, is if the one is positive and the other is negative, or the one is negative and the other is positive. Right, so let's look at the behavior. So I actually think that the easiest function to use as an anchor, if that makes sense, is the hyperbola, because it's very clear that here g gives us negative values, and here g gives us positive values only, right? So I think this is actually a blessing. It's just very clear to me. So I am going to highlight this. Okay, so g of x is negative over here, and g of x is, oh my gosh, scrawny little highlighter, and it's positive over here, right? And now, to be even more specific, like we're more concerned with the x values, right? So to be more specific, these are the x values that give us negative function values for g, right? And these are the x values. These are the x values that give us positive positive function values for g, right? So now let's start by looking at case 1, right? So within this interval of x values, where is f of x giving us positive or 0 positive values or 0, right? Where is f outputting a positive values or 0 values? So we can see that from this little point here, right, f is also outputting negative values. So we're not concerned, we don't want this piece of the function, because here if I take this point, well, this output, and I multiply with this output, I'm going to get a positive number, which is not what we want. We want a product that's going to be negative. So we don't care about this piece of the function, we care about this part of the function, right? Because here f of x is giving us positive values and g of x is giving us negative values, so that works. So this is the piece of the function that we care about on this interval, right? So that means that it's actually here, it's these x values that work for our intents and purposes, because over this little interval we are getting negative g values and positive f values, and so the product is smaller than 0, right? So let's write that in words. Thankfully they've given us this x-intercept so that we know exactly where f of x starts giving us positive x values. Not positive x values, oh my gosh, positive function values. So we know that when x is between -3 and 0, let's not include brackets yet, right, we get negative g values and positive f values. Cool. Then we always have to think about whether to include or exclude the boundary. So square brackets, round brackets, or kanjani. So when x is equal to -3, g gives us a negative value, f gives us a 0 value. And if you times those together, then you're going to get something equal to 0, which is fine, right? Because here we're looking for a product smaller than 0 or equal to 0. So -3 is part of the solution, right? And then when x is equal to 0, g is not defined, right? Remember, x equal to 0 is an asymptote. So we can't include 0 because one of our functions is not defined when x is equal to 0. So that's one part of the solution. I wonder if I'm going to be able to move this. A girl can dream, and so far it looks like my dream is coming true. Okay, so I'm going to move this down because we be done. Should I move it down or should I move it up? My hands go up and they stay there. And they stay there. And they stay there. Yeah, copy. Right, okay, so the next case is the case where g of x is greater than or equal to 0, and in fact it can't be equal to 0 because this is an asymptote. Y is never equal to 0 for this function, so it is erroneous. Well, it's not erroneous, it's just g of x can't be equal to 0. Like, anyway, fun fact. So we're looking at, okay, these x values because they give us a positive value for g, but we need f to be negative. So we don't care about this piece of the function because f is positive there, but we do care about this piece. So let us highlight that real quick. Right? So that means that from this x onwards, we get function values that satisfy our inequality, because f will be negative but g will be positive, and if you times the values together you'll get a number smaller than or equal to 0. So again, thankfully we've been given the x-intercept there, so we can just say this will also be true for if we pick any x value from 5 all the way to positive infinity. Okay, so obviously we can't include infinity. Do we include 5? Yes, we do, because when x is equal to 5, g gives us a positive output, f gives us 0 as an output, and if you times those together we get 0, so that does satisfy this inequality. So we included the 5. Right, so all in all, we can say that if we choose an x that is either in this interval, so between -3 and 0, or union with the other interval from 5 to 8. 5 to 8! 5 to infinity, just because it looks like an 8 lying on its side, my goodness. And the memo is in agreement, which is absolutely awesome. Right. Do I really want to rewrite everything that I rewrote on the other page? I don't. Let's see what the question is asking us, and then I'll really fully decide. So the next question asks us to calculate the values of k so that h of x is equal to -2x plus k will not intersect the graph of f. So if we're to imagine a graph of y is equal to -2x, maybe looks like that, right? So this is just where it's going through the origin where k is equal to 0, really. And we can see that, okay, it's intersecting with the graph, it's intersecting with it here, and presumably, like if we draw the parabola extended a bit more, it's gonna intersect with it again a bit further down. We are looking for the values of k so if I'm to move this up or down, how much do I need to move it up or down so that eventually it just doesn't intersect with the parabola at all? So it feels like, there's a certain point here, where it stops, where it kind of is a tangent to the parabola, and then from there onwards it just doesn't intersect with it anymore. And I think if we move it downwards, it's just always going to intersect with the parabola going this way, right? Like it's just the ruler disappeared. Interesting. Anyway, so so now we want to find, okay, what is the k where it doesn't touch the parabola anymore. In other words, okay, so we know that we can find the intersection between oh gee, here I am looking at the parabola. Oh my gosh, I was looking at the parabola. It's not a joke, it's not funny, but anyway, the same idea applies. So we have y is equal to 2 minus 2x, looking something like that. And honestly, it kind of looks like it wouldn't intersect with the hyperbola, like, and just to be clear, like I'm looking at this side of the ruler. Okay, it doesn't look like it would intersect with the hyperbola. And if I kept moving it like this, and then it would get to a point where it touches it as a tangent, and then it would intersect with it twice from then onwards, forever and ever. And likewise going this way. Okay, so now I'm looking at this side of the ruler as my line. if I were to, is it actually not better for me to just draw a line, you know? I wonder. Yeah, I think it would be better. It's clearer. And then try to move it. I like to move it. Yes, that's so much better. Okay, yeah, so here it would be a tangent, intersection, and then no intersection, and then, yeah, then we're back to intersecting. So there's a sweet spot between two k values, I think. And mind you, the k values really are just the x-intercept, right, of this line. So there's a sweet spot where a little closed interval where it's not intersecting with the hyperbola at all, and we need to figure out what that interval is. Okay, so in order to find the intersection between g of x and h of x, we equate the two, right? So g of x we know is 8 over x, h of x is negative 2x plus k, right? And this is the same as 8 over x is equal to negative 2. Okay, we're going to put this over x as well. So we're going to times by x. Top and bottom. So now we can just ignore, so of course, restriction on the equation is that x can't be 0. So now we can just look at this, right? So the solution to this equation will tell us the x values where these two graphs intersect. Now, we are looking for the values of k such that this equation has no real solutions. There are no intersections between the two graphs, right? So we're looking at nature of roots, which means we're looking at discriminant, which means first of all we need to get this into the standard, to look like a standard quadratic equation, right? And we get that by adding 2x squared on both sides, minusing kx on both sides. So now we're just left with 0 on this side. So now the discriminant of this equation is minus k squared minus 4 times 2 times 8, which is the same as k squared minus 64. Okay. And what we want to know is, we want to know for which values of k is the discriminant negative. Right, so for which values of k is k squared minus 64 smaller than 0. And this is a parabola we can sketch real quick, right? So we plot k versus k squared minus 64. It's pretty much a parabola that looks like this, right? Where this is minus 64, and these guys over here, k squared minus 64 is the same as k minus 8, k plus 8. Right, meaning that our x-intercepts are negative 8 and 8, right? So k squared minus 64 is negative over here, right? Which in other words is when x is between negative 8 and 8. Right, do we include these two? Well, when k is equal to this or this, then k squared minus 64 is 0. we are looking strictly for the places where k squared minus 64 is smaller than 0. So no, we do not include these two. Right, so that is our answer. That tells us that when k is somewhere between -8 and 8, then the straight line doesn't intersect with the graph of G. Agreement? Memo? Memo, please. Yeah, I'm not really interested in the alternative solution. One of those days where I just don't really feel like hurting my brain too much. 5.7, H is a tangent to G at R, a point in the first quadrant. Calculate T such that y is equal to fx plus t intersects G at R. Oh my god, what is happening? Oh, what? Oh, the pain. Okay, wait, what's going on? H is a tangent to G at R, a point in the first quadrant, some point. So let's just choose a random point. We choose this guy to be our R. So then the tangent would look maybe something. Okay, something like that. Right? Then calculate t such that y is equal to fx plus t. So this parabola, we need to move it up or down by a certain amount so that it intersects G at R. So in this case, we would need to move the parabola down a bit. So let's just say I'm going to try my best to trace this parabola. It is not going well. Anyway, so I thought that counts. Right, so we want to move it down by a certain amount, by a certain number of units, so that it intersects with a ring. It intersects with the hyperbola at the point R. Okay, so we're studying there, and then we're looking for the t such that it's going to intersect. Okay. Right, so for example, if the... Okay, am I going to be able to get this line? I don't think so. I got it. So let's say, for example, I don't even think I need it anymore, honestly. So let's say the R was here instead, then the tangent would maybe look something like this. Okay, then we would want to move it. We would want to move the parabola. We're just moving it up or down. Okay, in this case we would need to move it up so that it intersects there. Yeah, because if we move it down, it's just going to get further and further away. Hey, my dot. Where? How are we going to find it? How are we going to find it, detectives? Wow. So first I want to find, so first of all, right, this point R has coordinates x and, well, let's just make it a different letter altogether, right? So let's say little r, if the input is r, then the output is 8 over r, right? So those are the coordinates of r, right? And then we want to find a t such that this f of x plus t will intersect g at r. So we want to find a t such that f of x plus t, you know, f of r plus t will be equal to g of r, right? That when x is equal to r, this is where the outputs of the functions will be the same, of the two functions will be the same. And just to be very clear, f of r is negative a half times r minus 1 squared plus 8 plus t, and g of r is equal to 8 over r. Okay, no, wait, I don't want to do this algebra. I don't want to do this algebra head first. I need numbers. First and foremost, I need numbers because I don't really know what I'm trying to do. So what I am going to do is to first try and do this with numbers, right? Because as we've seen, r could be anywhere, really, as long as it's somewhere in the first quadrant, right? So let's just get a random r. So let's say experimentation, right? So let's say let r be, what's a nice r? Let's try 1, right? Then the y coordinate will be 8 over r, which will be 8 over x, which is 8, right? So now, oh, we do already know 1 and 8 is the turning point of the parabola. So in this case, t is 0. H is a tangent to g at r. What is h? H is a tangent, okay. Calculate t such that wait, is there actually an r in the diagram? Because now this is gonna get awkward. Let me just make sure that I've copied everything across before life gets very weird. Because h, for this one, r is 1 and 8. That would be the turning point, and the tangent would be the line y is equal to 8, and f of x intersects with g at r as is, so it wouldn't have to move up or down. So t would be 0 in this case. But if we were to choose a different r, so if we had chosen, for instance, r is 4, right? Well, x coordinate being 4, y coordinate would be 8 over 4, which is 2. So maybe something somewhere here, I don't know. Then the parabola might have to move down to intersect. And where does the tangent get in, you know, like ingenap? I'm not giving. Wait. Just double check the question. Okay, so I haven't missed something. Hey, okay, let's just continue with experimentation. So for this one, we said t is equal to 0 because the parabola and the hyperbola already intersect when at that point 1 and 8. But let's see for 4 and 2, and hopefully I haven't picked another point of intersection. Anyway, so calculate t such that y is equal to f of x plus t intersects g at r. So we would be looking for a minus a half, so the x would have to be 4, and we want to add something to this parabola so that it also has an output of 2 when x is equal to 4. So then that would be minus a half times 3 squared. Okay. And then we would have negative 9 over 2, which is negative 4.5, plus 8, which is 3.5. Okay. So then t would have to be, so 2 is the same as 4 over 2, so that would be negative 3 over 2. So really it's gonna change depending on which r we choose. Hey, this question is so confusing. Let's see what the memo is saying, guys, because I have a feeling there's a piece that we are missing. So in the memo, these guys go straight to, oh guys, is the h from here? Oh my word, it's a continuation. Ha ha ha. Ha. H is attached. Oh my gosh. Okay, sorry. Yo. Context. Short-term memory failures. Right. It is not a coincidence that they have, just used the same function name as, the previous question. Yo, what am I doing? Okay, right, so this is why it was important for them to tell us which quadrant the point is in. Right, so the h is from here, guys. The h is from here. So h of x is equal to negative 2x plus k. Anyway, so it is a tangent to g at r, some point in the first quadrant. Okay, so our tangent really is one of two choices. It was either gonna be, so if this is our y is equal to minus 2x, right, then this is the one tangent, y is equal to minus 2x plus some number, or the other tangent would be here, y is equal to minus 2x plus some other number. So we've been told that the tangent that we care about is the one in the first quadrant, well, to the point that is in the first quadrant. So this is the one we're looking at. Right, so, oh, maybe I want to draw it. Maybe. Wow, that was so painful. Right, so this is the tangent we are contemplating, deliberating. Okay. Right, and this is our r. Okay. calculate t such that y is equal to f of x plus t intersects g at r. So we need to move this parabola presumably down so that it crosses the hyperbola there. Okay, so first of all, we need to figure out what is the there. Right, so we need to figure out where does this tangent occur. So we know that the tangent has an equation y is equal to minus 2x plus k, i.e. its gradient is minus 2. So we need to figure out, okay, which point on the hyperbola, or which points on the hyperbola have a gradient. I can't say a point as a gradient, but just bear with me, of negative 2, right? So where is the first derivative of g equal to negative 2? So first of all, we know that g of x is equal to 8 over x, which is equal to 8 times x to the minus 1. So g prime will be negative 8x to the negative 2. So we want to figure out where is this equal to negative 2. And this is low-key fraction with x in the denominator, so we have to note gently to ourselves that x can't be 0, because that would just be a violation. Right, so divide by negative 8 on both sides, and we have x to the negative 2 is equal to a quarter. Yeah. Then we can raise this to the power of negative 1. So this would be x to the 2 is equal to 4. And so x would be equal to plus or minus 2. Right? But we know that x is greater than 0 because it's in the point we're talking about is in the first quadrant. So therefore really x is equal to positive 2, right? So we now know that the x coordinate of r is 2. Okay, and now I would like to figure out the y coordinate, right? Because once I figure out the y coordinate, I can also then figure out, okay, what is the y coordinate of the, what am I saying? So I want to figure out, okay, if I look at the point 2 and something on the parabola, right, if it's currently at 10 and this guy is at a 7, then I know that my parabola needs to move down by 3 units in order for it to intersect with the hyperbola over there. So that's why I want to find the y coordinates. Okay, so so we want to find the value of the function when x is equal to 2, so that will be 8 over 2, which is 4. Right, so first of all, I know that I've sketched my r very poorly, which began by me sketching my tangent very poorly. Okay, so I want to figure out, okay, what is the value of the parabola? The parabola function when x is equal to 2, which is minus 1 minus a half times x minus 1 squared plus 8, which is minus a half times 1 squared, which is 1 plus 8. 8 minus a half is 7 and a half, which is 15 over 2. Okay, I'm going to keep it as 7 and a half really. Right, so now I know that the gap here is 3 and a half. If I can just move this parabola down by 3 and a half units, then it will intersect with my hyperbola over there. Right, and that is what we want, right? We want to figure out how much we need to move the graph, this parabola, by in order for it to intersect the hyperbola at r, and the answer is 3 and a half units. Ugh. Okay, and we're moving it down, so that will be negative 3.5, negative 7 over 2. Of course, another way that you could have done it is to say we want f of x, well, not f of x, we want f of 2 specifically plus t to be equal to g of 2, right? So then we can solve that equation. Well, that's really just what I did, honestly. So that would end up being 7.5 plus t is equal to 4, and t is equal to minus 3.5. What's another way we could have done it? Let's look at the memo. Now that I understand. So the memo somehow the memo just gets off from the starting blocks with h of x is equal to minus 2x plus 8. How do you know? How do you know? I guess from the previous question, we know that when k is between negative 8 and 8, the straight line would not touch the hyperbola. So when k is equal to negative 8, or when k is equal to 8, that is when it would be a tangent to the hyperbola. So yeah, that is how you would know straight from the jump that h of x in this case is minus 2x plus 8. Then they equated to 8 over x to figure out, okay, where are they intersecting? And they found that, okay, it's intersecting when x is equal to 2. And then they figured out the y coordinate at that point. Well, the y coordinate of the parabola when x is equal to 2, and of the tangent or the hyperbola when x is equal to 2, and then they figured out the difference from there. Okay, cool. The alternative, yeah, okay, we're not really doing anything very different here. Okay, cool, interesting question. Remember to keep context from previous questions, I guess. Honestly, I would have done like a 5.6.1 and 5.6.2. But yeah, who are me? Thank you. Bye.